Hey everybody. Today we are going to go back through sine and cosine, but we're going to talk about how to transform these graphs. So before we do that, we just need to identify the parts. This is the same things as we did to all the parent functions. We slid it up, down, left, right. We had vertical, stretch, shrink, reflection over the x-axis. It's all the same things. We will not reflect over the y-axis, but we will do all the rest of this stuff. We just have to define some of this stuff because the words are different. So the amplitude is the first term. So the A, right? That's where your amplitude is. It's actually the absolute value of A because the negative sign would make it reflect. So we want to think about the amplitude as being a positive number. And you can find it by taking half of the max minus the min. So if you have a graph, you can find the high and the low point, subtract them, and divide by 2. It's basically the measurement from the midline up or from the midline down. So that's how many spaces we would count up or down from the middle of the graph. And we'll talk about what is the middle of the graph and how do you know where the middle is. Generally, it's that horizontal axis, but doesn't always have to be. Now, the period is one cycle. So how long basically does it take, sorry, I'm trying to talk and right, didn't come out so good. How long does it take basically for that paint to go all the way around? Or how long does it take the circle to go all the way around, the values, to go through all of the different numbers, all the positive, all the negatives? And on the picture, it can be measured from the max to the max or from the min to the min. So it's basically a straight line measurement. So it's measured max to max or min to min. So high to high or low to low. The formula to find it is 2 pi over b for sine and cosine. It's not that for everything, but in order for sine and cosine to go around, go through one cycle, it's 2 pi divided by b. And of course, b is the term next to x. What parameter causes a vertical stretch or shrink or reflection? That would be A, not the absolute value of A, just the value, just A. We're really going to call it amplitude. We will not call it vertical stretch or shrink. Now, which one causes a horizontal shift? We will move these things left or right, and that's in the same spot. That's C. Or it could be C over B if B is inside the parentheses. And again, we will go through examples of both cases. Of course, the easiest one still is the easiest one. Up or down, vertical shift is D. And these are the words we will use. Vertical shift, horizontal shift, amplitude, and period. And you'll see as we go through. Those are the words. So if we take a look at just the first two, amplitude and period are the ones that you're going to be asked about the most frequently. So let's just take a look at what that looks like on a picture here. Sorry, I can't get this lined up. So it says find the amplitude and the period. Well, the amplitude is half of the max, which is 3, minus the min, which is -3. 3 minus -3. So half of 6 is 3. Or essentially, it is, if you go from the middle, how high up does it go? Or how far down does it go? So you can see on this graph that the middle is this axis right here. This is called the theta axis. Now the period is measuring it from high to high or low to low. So I'm going to pick on these two spots right here. This is my high and this is my high. It's basically a straight line measurement. So this is your period. When we have an equation, we can do 2 pi over b. We don't have an equation, so we don't know what b is, so it makes it a little bit hard. Now, you're going to have to pay attention to your scale. This is pi right here. So this is pi over 2. So the high, the first time is pi over 4. So if that's pi, then this would be 3 pi over 4. So you have to sort of count in the radians. So our period, of course, would be 3 pi over 4 minus pi over 4, which is 2 pi over 4, or pi over 2. The second one is a little bit easier, a little bit different. So again, the period, if we do, let's put this up here. It looks like it starts at 0, and the next time it's high again is right there, so we know that that's 2 pi. And then the amplitude, now that you have a better eye for it, from 0 up or from 0 down, the amplitude is 4. Amplitude is always positive. So let's actually draw some of these graphs using this information. If it's still a little bit unclear, just hang in there. You'll see how this works. So the value for A is the number in front. So we know that A is 1, and the value for B is the number in front of X. So we know that B is 2. So before we can do anything with the axes, don't just do like you normally would, 1, 2, 3, 1. We don't do it like that with these. You've got to figure out all this information, and then we make the axes what we need, and only what we need. Let me show you. So we know that the period, this is on your theta axis, your x-axis, is 2 pi over b, which is 4. So it's pi over 2. So the way we're going to do this, and we're going to do it the same way every time. All right, notice in my graph, I'm graphing positive numbers only to the right. So this is my theta, so I'm only graphing positive angles. Now, obviously, I can go up and down on my y-axis, but we're going to go 1, 2, 3, 4, period goes here. Period always goes on the 4th mark. Only make 4 marks. Then we're also going to mark the halfway mark. So pi over 2, half of that is pi over 4. Now, for your amplitude, the amplitude gets marked on the y-axis. So we know we have to go up 1 and down 1. If you go up 7 and down 7, it could look the same. Now, graphing the cosine. Cosine starts high, ends high. Halfway, it's at its low point, which would be -1. And in between there, it's right on that axis. Again, we're finding the amplitude, which is the number in front, 1, and the period, which is 2 pi over b. Now, b is the number in front of the x, which in this case is a pi. So our period is 2. That's okay. That can be a radian measure. It doesn't have to have a pi in it. 1, 2, 3, 4, 2, halfway. Amplitude, 1, -1. This one is sine. Do you know your sine graph? Sine is 0, beginning, middle, end. Sine goes up before it goes down. So halfway between the two zeros, it goes to the maximum. Halfway between these two zeros, it goes to the minimum. We're going to graph these the same every time. You have to manipulate your axes. All right, so here we've got a reflection. So we know that the amplitude is 2, not -2, but 2. The period is a fraction in front of the b, or in front of the x. So be careful. When you have a fraction, you got to make a complex fraction. It's 2 pi over 1 over pi over 2. If you're going to do 2 pi over 2, that problem is going to be a little bit harder to figure out. You're going to have to do 2 pi times 2. You're going to have to do a lot more work. I'm going to show you a way, oops, I thought that was the eraser, that we're going to do basically no work at all. No, I can't erase this. There we go. I thought it was funny trying to use up all my space here. All right, so with this complex fraction, we're going to take the very, very high and the very, very low and multiply them together. That's going to be 4 pi. Then you take the middle two and multiply those together. That goes on the bottom. This is just pi. So you can see our period is 4. It's my tricky complex fraction. 1, 2, 3, 4, 4, halfway 2, amplitude up 2, down 2. Now you thought I forgot about something, but I didn't. This thing also reflects. So we reflect and when we graph it. So we're going to think through it. This is cosine. Cosine's supposed to start high and end high, but we have to flip it. So cosine is going to start and end low, which means halfway it's high. And then in between these other two, it's right at 0. Please connect this with a smooth curve, not a V shape. For number 4, period. 2 pi over b. Amplitude, 1. I did that kind of randomly. Sorry, you just need both answers. So if we're going to go 1, 2, 3, 4, 2 pi over 3. 2 pi over 3 times 1/2 is 1 pi over 3. Now, hopefully that just makes sense, right? I'm just counting by pi over 3s. Amplitude, 1, -1. Now we're going to graph sine, 0 beginning, middle, end. Goes up before it goes down. So here's everything. You can see you've got a little list out there to fill out. This is what your homework looks like. Some tips on success. Make sure you label both axes. It's the only way we know that you understand how the axes work. I'm going to go through and find the parts first and then sort of figure out what I'm going to do with my axes from there. Amplitude, first number. Period. Okay, there's a b is my fraction. So again, my trick, 2 pi over 1 over 1/4. Very high and very low. That's your numerator. 2 in the middle, that's your denominator. So our period is 8 pi. Now we really don't care. It could be 1,000,000 pi. We label it the same. Vertical shift. According to this, it's right because there's a minus. And the number is pi. Horizontal shift. Oops, that is my horizontal shift. I was just going in order. Pay attention. So we have right pi. And then, of course, our vertical shift looks like it's up 2. All right. So we know we have to go up 2, and our amplitude is 3. So we know we have to go up to 5. Also, from up 2, we have to be able to go down 3. 1, 2. So we have to go at least go down to -1. 1, 2, 3, 4, 8 pi. Halfway. Now, figure out how many spaces, so we're moving to the right pi. This is 2 pi. So on our graph, this is half a space. Sometimes 1 pi is 5 spaces. In this case, ours is only 1/2 of a space. So we got to keep that in mind. Figure this out based on your graph, not based on the last graph you did. Now, for the up 2, I'm going to redraw a midline. So this is going to be my new midline. I'm going to count everything from here. I'm going to make it a dotted line just so I can find it. And because I'm moving to the right, I need to know if looks like we're counting by 2, so this is 10 pi, because I need to know where 9 pi is, because I'm moving to the right 1. So I'm going to graph this twice. I'm going to graph it, and then I'm going to move everything to the right pi. So I'm going to do like a graph before the graph, a ghost graph. So my first graph is my regular sine curve. Sine has a 0 in the beginning, the middle at 4 pi, and the end at 8 pi. It goes up. Now my amplitude is 3, so I have to go up 3, and I have to go down 3. Now if you want, you could also make dotted lines to help you find the max and min. This will help keep your graph sort of nice and organized, but it's not something you have to do. It's totally optional. Drawing this midline, not optional. Draw it. Now that's my ghost graph. I'm not going to connect the dots. But what I am going to do is I'm going to move all the dots 1/2 of a space to the right. So this one right here is going to move here. And I'm going to make a different symbol so I can figure this out. This one moves 1/2 space to the right. 1/2 of a space to the right. It's kind of an estimation. 1/2 space to the right and 1/2 space to the right. So I'm going to connect these little stars that I made. And that's my graph. After all the transformations. So for this one, you can see the amplitude is 4. The period, B is inside the parentheses. So if you look back at the notes, it's C over B when B is inside the parentheses. So it's really touching that X. I want to make sure I didn't do that other one wrong. Sorry about my switch around. So our C is pi. And our B is 3. So the period, oh wait, I'm sorry. I'm doing vertical shift. I'm getting way ahead of myself. Back it up, Betty. All right. So our period will continue to be obviously 2 pi over B. So 2 pi over 3. The horizontal shift. So left and right. This is going to be, it's minus, so it's right. And then you do C over B. So pi over 3. It's not right pi, it's pi over 3. And the vertical shift, of course, is a minus, so we're going down 1. All right, so now let's figure out what we have here. 1, 2, 3, 4, 2 pi over 3, pi over 3. Oh, so write pi over 3, that's 2 spaces. See how it changes every graph? So you better make sure you have 2 spaces labeled, which is just 3 pi over 3 or 1 pi. Now our amplitude, we need quite a lot of space here. So we're going to start down here at -1, and we have to be able to, from there, go down 4. So we have to be able to go to -5. We have to go up 4. Now, if you want, you can make those dotted lines. Here's my new midline. I count from here. And of course, I'm going to draw my graph before the graph, cosine. Starts high, ends high. But remember, it ends at 2 pi over 3. Halfway, it's down. And then on the red line are my zeros. Now, I'm going to move the graph. In fact, I'm going to move every one of these blue points 2 spaces to the right. 1, 2. This gets kind of confusing. Have a method to your madness, because like this one overlaps, which definitely happens. What'll happen is you'll notice you've forgotten one. Just go back and fill it in. You've got to have these points on here. The graph is really hard to draw without it. I know that sounds silly because there's not very many points, but it's so helpful. I don't know why I put all those little extra spots, but you know that's what the curve does anyway. So there you have it. So try your graphs. Just try them. Just go for it and try it. And if it doesn't go well, that's okay. We can fix it. Just give yourself a try so you know what it is that you're struggling with.